Assalamualaikum and hi to Doctor and others. We are from the group 3 and we're gonna present the report for experiment of minor losses in pipe. For our teammates, we have Hafiz, Govidran, Afifah and Aisha. For the introduction of our experiment, you should know that fluid only moves through the pipe when compelled to do so by gravity or pressure from a pump. The measured pressure at any point in the pipe is observed to drop when the flow direction changes. This pressure loss results from friction inside the liquid as well as between the liquid and the pipe wall. In order to create a closed loop, the fluid flow device seen in figure 1 use a pump to force water from a holding tank through a network of pipe and back into the tank. The pipe has several valves that, depending on whether valves are open or closed, may be utilized to make the water flow through any or all of the five pipe displayed. If the valves are closed, then no water will flow. The pipe system also includes a rhodometer, which is flow meter, aligned with a venturi and orifice plate, aligned with globe valve and a gate valve, aligned with a section for expansion and contraction, and aligned with the square and circular bands. Numerous pressure tapping are located along the pipe, allowing for pressure measurement. This is a cleavage by pressure transmitter which provide the H2O pressure in inch. Bernoulli formula may be used to determine the pressure change from one place to another for fluid moving in a piping system with full pipe. If there is no pipe between position 1 and 2, this formula produces. And this is the formula that we use in our calculation to calculate the minor losses, which is HL. As you can see, HL is a heat loss which accounts for energy losses due to the friction in meter. And for the Z1 and Z2 is height of water in the piping system relative to a common reference height. And for the P1 and P2, as you know, is the pressure of the static pressure in the pipe. And when the diameter of the pipe does not change, the velocity will also remain constant. For the objective and scope of our experiment is to find pressure loss, which is minor losses, for the several pipe component over a range of flow rate and compare the experiment finding the theoretical calculations. For the theory or working principle, energy is lost as fluid passes through the system of pipe because of friction with the wall as well as any blockers, bend, expansion or contractions that cause the fluid to change its flow rate. This distribution leads to the minor losses which are linked to second, change its flow direction. For the example, energy loss results from the turbulent eddies or N-vortex form brought on by elements like elbow, bend, and teeth that alter the direction of the flow. Second, flow area change, which is rapid increase or decrease in pipe's diameter result in energy losses because the fluid flow slow down or speed up. First, you should know that at increasing flow velocity, minor losses tend to rise. Second, fitting with the large area charge and abstract twist typically have greater abstract, which is diamondless, or fitting loss coefficient value because we have 45 band and 90 band of the pipe. Third, to reduce energy needs, system design frequently take into account the cumulative effect of small losses which can be sustained in the entire pipe system.
Next, this is the experimental setup. In the experimental setup, we have inlet valve, two tube manometer tube, tested pipe section, and outlet valve. And then this is example of the components of the device in this experiment. So next, we move to the methodology. For the first step, the direction of the water inflow and outflow through the pipe were determined, and then the main switch opened. Next, the inlet valve of selected pipe section in parallel were opened. Okay, next, switch on the pump, and then we open the control valve counterclockwise until the maximum slowly and wait for a while to remove air bubbles in the flowing pipe. And then we identify inlet flowing pressure for H1 and outlet flowing pressure for H2, and then connect the manometer tube. And then after that, we record the values of H1 and H2 in millimeters of the inlet and the outlet of water manometer. After we record the values for H1 and H2, push the valve at the bottom carefully and then record the volume of water collected at the tank with the time for measurement of the flow rate of water. Then the outlet valve was set to 5 different flow rate and step 6 were repeated. After that, when finished the experiment, the manometer tube were removed first to prevent bubbles from forming in the tube, and then the inlet related valve for the next pipe was opened and non-water flow related valve were closed. Then step 5 until 9 were repeated for other tested pipe section, and then when finished the experiment, all manometers tube were removed from the system. The inlet and outlet valve were fully closed and the main switch off. And finally, loss coefficient and minor head loss were calculated using equation and the values were recorded in the table. Next, this is the in case if bubble in system or manometer full. For the first thing, we need to connect the manometer tube to any pipe section, and then we need to fully open inlet and outlet valve of the pipe, and then open the vent valve at the top and let all the air bubbles out from system. Once done, close the vent valve and close both the outlet and inlet valve of the pipe and then turn off the main switch. To setting zero position of manometer, we need to open vent valve at the top 2 rotation and slowly open both of drain valve and then let the water at the center of manometer scale close and also close vent valve, and then we need to turn on back the main switch.
Hello. Okay, so here's a result for our experiment on the standard animals and standard construction. We decide to make the volume of the water collection is 2 liter, and this our result for the time QF, and that is flow rate, volume flow rate, and the pressure of H1 and H2, and the average pressure for the each five reading we take. So here the next for the slide is here a Y type and T type of the pipe section. So the volume of the water collection is the same, 2 liter, and the timer and the volume flow rate for the each reading. This here we take the 5 reading also, and here the H1 and H2, there is a pressure for the inlet and outlet pipe section, and the uh, average pressure for the each pipe section for the 5 reading. And here this for two times angle 90 and 2 times span 90. And also the volume of the water collection is 2 liter, and you can here look at the result we get for the times for collecting the 2 liter water, and the volume flow rate for the volumetric flow rate for the each pipe section. And also we have the pressure for each water flow in the pipe section for the 5 reading tape. Okay, lastly here we have the 2 times angle 45. So you can see the result of this table. Also, the volume water collection is 2 liter, and the volumetric rate is calculate, and here is the pressure, the flow rate of water. The pressure of water inlet and outlet for the pipe section, and the average of pressure of water. So here, after we get all the result and in the experiment, we must to calculate the minor heat loss (HLM) and loss coefficient (KL) value for each pipe component of heating. For the note, major losses (HL) calculation: set the temperature of flowing medium at temperature 36 degrees Celsius and determine the coefficient of friction F using a formula of Celsius. That is F equal to 0.3164 over set for RE. So here the properties table for the kinematic viscosity at the certain temperature, and we must to find the kinematic viscosity at the temperature 36 degrees Celsius. So after we get the kinetic viscosity at the temperature 36 degrees Celsius, we must to calculate the for the standard adjustment first. So for the standard adjustment, we must to find the diameter of the inlet. So we shall formula D1 inlet equal to D1 outlet minus 2T. So here we have the D1 outlet is 0.02 minus 2 times with T. T here is thickness of the pipe 1.5 exponent negative 3, and we can get the 0.017 meter. So after that, we must calculate the outer diameter D2O equal to 32 millimeter. So uh, we change the unit from millimeter to meter and use the same formula, and we can get the 0.0284 meter. After that, we must find the cross-sectional area of the upstream. That is a formula is pi d pi d sorry. So here we must find the cross-sectional area for the inlet first. So pi d inlet over pi d inlet square over 4. After that, we can get the 2.2698 exponent negative 4 meter square for the area cross-sectional area for inlet. So we use the same formula for the outlet. So we can get the 6.3347 exponent negative 4 meter square. So after that, we must to calculate the relative viscosity. Use this formula, and after that we can get the viscosity for the temperature 36 degrees Celsius is 0.7148 exponent negative 6 meter square per second. So after we get all the cross-sectional area for inlet and outlet, we want to find the KL, that is the loss coefficient. So with the formula 1 minus A inlet over A outlet square. So after that, we can get the 0.4117. So the loss coefficient is used for the all pipe reading at the sudden enlargement, because we use the same pipe section. So after that, we can find the V1, V2. That is a volume flow rate for the each for the each inlet and outlet. After that, we can get the RE uh, friction of the we use the Bacillus formula, and after that we can get the HLM. So after we get all the information, we must to average total up and divide divide the total sum with 5 to get the average of minor heat loss (HLM), and loss coefficient KL, and average coefficient friction F. So for the Cartan contraction, we use the same formula at the LS for the element. Uh, here we use the inlet for the uh, inlet for the Cartan contraction is 32 millimeter, and for the outlet is 20 millimeter. So the thickness and the length of the test bed section is the same at the southern element, and all the kinematic velocity also the same. So after we get the calculation uh, at the before slide, we calculate the Q, V1, V2, RE, friction, KL, and HLM. After that, we calculate the average of HLM, loss coefficient, and average coefficient friction F. Use the same formula. Uh, same with the before. Same with the standard LSP. So here is the Y type. The position is a Y type. So here first we must to find the D outlet. D inlet. D inlet is equal to D outlet minus 2D. Here the Y type diameter of the inlet and outlet is same. So just a section of the pipe is different. So here we can get the diameter is 0.0170 meter. And after that we use the same formula to find the kinematic velocity at 36 degrees Celsius. And after that we use the same formula to also to find the all RE, friction, and HLM. Also the KL. Also for the KL, the kinematic losses, we uh, refer to the table at here, refer to table, and we can get the line flow for the flash is 0.2. So after that, we use this and calculate all the information below to find the average minor heat loss, loss coefficient KL, and average coefficient friction F. So here the T-type section. We must to use also the same formula for the DI, kinematic velocity, kinetic viscosity, the depth coefficient area, and the loss coefficient KL. We use the also the same table and also the same formula. And here the same formula for the calculation of V, RE, F, KL, and HM. Also for the T type and Y type, we just calculate for the one V because it's not a different diameter, so that not different velocity. So after that, we can find the RE, friction, KL, and HLM. So we must to find the average minor head loss, loss coefficient, and average coefficient friction. So for the 2 times 90 angle and 2 times 90 bend 90 and 2 times 45 degree angle, we use the same formula. Use the same formula for the internal diameter, cross sectional area, and kinematic velocity, and also the loss coefficient. So for the loss coefficient, 2 times 90 angle is 3.0, and for the 2 2 times 90 bend is 1.4, and for 2 times 45 degree is 0.8. So here the calculation about the V, RE, F, friction, KL, and also the HM. There is a head loss, minor losses. So with the same formula, we must to use. And after that, after we get all the value, we must to find the average minor head loss. Loss coefficient is 3.0, and average coefficient of friction F. So here also we must to find the one velocity because it's different same diameter, and no different velocity at inlet and outlet. So here you can load the photo times 45 degree angle. The formula is also same, and for the difference is a load coefficient KF, that is 2 times 0.8, and we can get 2 times 0.4, and we can get 0.8. And here for the calculation velocity, RE, friction, KL, and HLM for the 2 times 45 degree angle. You can look here the same formula, and for the velocity also we find one just velocity for the inlet because the diameter is the same. And lastly, we have the 2 times 90-degree bend, and here the also the same formula for the internal diameter and cross-sectional area and the kinetic velocity, but the difference is a loss coefficient KL. It's a 2 times 0.7 for 190 bend. So here we have 2, so we must do time with 2, and we can get 1.4 for loss coefficient KL. And here the lastly for the calculation of the 2 times 90 band, 90 degree band. So here the also the formula same, and the velocity of this experiment is v for this pipe section is 1, v velocity have just 1 because have the same diameter. The velocity inlet and outlet is same. Okay.
Okay, here we will see the effects of different water flow rates, pipe diameters, and pipe bends on the value of loose coefficient. The equation for water flow rate Q equals to AV, where the V is the velocity of flow in the pipe, where the minor loose occur. If V increase, the flow rate Q will also increase. The loose coefficient has no dimension since it represents a proportional content between the energy loss and the velocity head. The magnitude of the loss coefficient is determined by the fracture of the system causing the head loss and velocity of flow. If the water flow rate is high, the friction loss in the pipe is greater. Hence, the loss coefficient is also greater. When water flow from a smaller pipe into a large pipe through a sudden enlargement, its velocity will increase rapidly, cause frictions, and resulting the minor energy loss. The minor loss due to sudden enlargement of the pipe can be estimated by integrating the momentum. When water flow from a large pipe into a smaller pipe through a sudden contraction, the fluid streamlines will converge just downstream of the small pipe, known as vena contraction phenomena, creating a turbulent region from a sharp corner in the small pipe and extend past the vein contraction, which subsequently generate an energy loss. The smaller the pipe diameter, the more friction will contain and more energy will lose, hence the higher of the flow coefficient. Losings in fittings such as elbow, valve, and etc. have been found to be proportionally to the velocity head of the fluid following. The larger of pipe bending, the smaller the loss coefficient. Factors that contribute to error or inaccuracy in experiment data and the possible recommendation to improve the aesthetic result. Okay. The factor contributing to error or inaccuracy in experiment data is parallax error will occur when the eyes are not perpendicular to the measurement scale. Besides, human errors such as mistaken data can also lead to calculation error. The presence of air bubbles trapped inside the connection tube which connect the pipe to the manometer affect the flow of water and leads to mistakes. The frequency of the manometer column higher due to the unstable flow rate during experiment will affect the accuracy of data taken. Furthermore, environment environmental factors such as vibration, temperature change, and electric noise may affect accuracy of measurement. Hence, we need to take some precaution to minimize such factors to improve the accuracy of data taken. We need to make sure that our eye level is perpendicular to the measurement scale during taking data to avoid parallax error. We also need to make sure that we take the correct data and repeat calculation to get the correct answer. Besides, we need to remove all trapped air bubble by opening the ventilation valve to allow the overflow of water before experiment. To avoid error caused by fluctuation of manometer column height, several readings should be taken and take the average reading of and to get the accuracy of H1, H2 answer. Lastly, we need to make sure that the environment that we experiment is in a safe and quiet condition.
And then this is the conclusion for this experiment. In conclusion, the losses coefficient and minor head losses in pipe component are affected by the flow rate 5 flow, sorry, head losses in pipe component are affected by the flow rates, pipe diameters, and pipe bends. Various type of pipe with sudden enlargement, sudden contraction, Y-type pipe, T-type pipe, 90-degree angle pipe, 90-degree bend 21 pipe, and 45-degree angle pipe were used to determine the loss coefficient with different volumetric flow rate. So the result shown that when the diameter of the pipe increase, the loss coefficient also increase as friction loss of a flow also decreases. However, when the flow rate of fluid increases, the head loss of the fluid and the loss of energy increase due to the increasing velocity. Therefore, the loss of energy and head loss also increases in the presence of pipe bends. The experimental value of head loss may be different with the theoretical value of head loss due to the several factors that affect the experiment value of accuracy. Thus, we can reach the conclusion that the lower coefficient losses contribute to high efficiency of the pipe system. The objective of this experiment is achieved as the loss of coefficient and minor head loss is determined through calculation. Then this is the some of the safety procedures during handle the experiment. For the first one is we need to always alert with the caution and handle carefully to avoid the pedal braking. Next, eyes must be perpendicular to the scale to avoid the parallax error. And then make sure the manometers were fully connected to the pipe flow to ensure the flowing water to be smooth. And then do not touch the switch with your wet hands and make sure you use with dry hand to avoid electric shock.
So here you can look the result of our calculation. No result for our experiment. We do in the lab. Okay, so thank you and see you in the next lab experiment. Thank you.